Hello, everyone, and welcome to Beyond Bandwidth, Leviton's podcast series where we dive into network technology's hottest topics. I am your host from Leviton Network Solutions, Roy Chamberlain. The discussion for this series is Distributed Antenna Systems, otherwise known as DAS. We are joined by today's subject matter expert, Leviton's own Mike Connaughton. So to start, Mike, what exactly is Distributed Antenna Systems?
So a distributed antenna system, DAS, usually what people refer to it as, it's a way of capturing cellular information from outside, so whether it's Verizon or AT&T, and bringing it into a building. It can be a variety of places it's done, but the most common space is in a building where your cell service doesn't work very well. Your phone doesn't pick up the carrier very well. So a DAS captures that signal from outside the building, usually from a donor antenna on a roof or someplace like that. It brings it inside the building and then distributes it to multiple antennas throughout the building. So that's what the name comes from. It's a distributed antenna system. And it works in both directions. A signal coming from outside gets pushed to your phone, but when you're talking on your phone, it actually goes back through those antennas in the ceiling, out through the antenna on the roof, back out to the carrier network.
So it's both directions with the passive systems?
Yep. The key piece of equipment that's usually in a passive DAS network, it's called a BDA, a bidirectional amplifier. So kind of in its name, it's telling you it goes in both directions. The reason you're using a DAS in the first place is because the signal's not strong enough to reach inside of the building. So there needs to be some amplification done. And that usually applies in both directions. So a BDA amplifies that signal in both directions as needed. An active system doesn't use a BDA. It becomes almost its own cell site, distributes the signal in a similar fashion, though. You can have multiple antennas scattered about the building and then feeds back into the head ends and then connects out into the carrier network.
Talking about cellular amplification and DAS, I've been in the industry for a while, and this has been going on, for buildings and different applications. But recently, especially over the last few years, I've been hearing more and more about DAS systems in general. What do you see why there's more demand for DAS than maybe there was 10 years ago?
I think there's a couple of reasons. One is, I think, just the use of cell phones as being a business necessity has been growing. If you think back 10 or 15 years ago, you might say most business people had cell phones, but certainly not all of them. I would say it wasn't your first point of contact. If I was trying to reach you, I tended to call your office phone first. And if I didn't reach you, there was almost like a courtesy. I'm not going to call his cell phone. Like that's not what you would do. That's not the way today at all. Today, a lot of people don't even have an office phone. The only phone is the cell phone. So it's become a requirement for conducting business. So if you take that thought process and apply it to, let's say that person's a salesperson. As a business, I want to make sure that if somebody's trying to reach my salesperson on the phone, that phone call gets through. The building designs haven't necessarily changed, but the technology has. We've gone from 3G, which I'd say is 10 years ago, through 4G into 5G. As those speeds get higher, the frequencies get higher, it's harder for that signal to penetrate even the very same building as it was attempting to penetrate 10 years ago. So I think a combination of that, the technology advancing so that the signal has a harder time penetrating the building. At the same time, there's more of a business imperative to make sure that signal gets through. So a DAS ends up being needed more today than it was needed, 5, 10, 15 years ago.
Okay, so as we increase the throughput, the actual signal itself has a harder time going through the building materials and the green glass and things like that.
Exactly. I mean, that's true of kind of any signal. But yeah, with the promise of 5G, because where we're at today, everybody talks about 5G, but we're really beyond 4G from a transmission protocol. Frequencies, it's kind of 4G. But the 3G, 2G is gone. 3G, it will be gone because the carriers or the government, the people who control the spectrum, they're going to want to reallocate that because there's only so much spectrum to go around. So they've taken it away from the 2G to make those frequencies available for 5G. But in order to pack, like you're saying, pack more capacity into it, there's various things that are done that increase the frequency of that. And by its nature has a harder time getting through There's some materials it doesn't have much problem with at all. But you mentioned green glass or e-glass, metal structures when you're below ground. I mean, there's certain places you'll be, it's fine. But then there's other places that it's terrible. And I think, we've all been there. I think of our own factory here. I sit in my office, the cell service is terrible. It's always been terrible. So we're actually putting a DAS into that structure, fully anticipating a much better cell service experience.
Right. You mentioned 5G. Can you explain exactly what 5G is and what its purpose is going to be? Or obviously it's to give you more throughput, but is that it? Or is there more behind 5G for the industry?
There's a handful of things. I mean, part of it is that the most, I'd say, apparent piece that's advertised is speed. But there are other capabilities that can come with that. One of the things that's built into it is capability called network slicing. If an owner of a system, this could be a carrier, it could be a DAS system, you can slice that up and apportion pieces of it to different people. So you could almost think of it as segmenting your drive on your PC to do different functions. So you can allocate different pieces of it. One of the big and early use cases of that is in private networking, which is really around, at least today, production. That's one of the things we're going to use it for here in Fuquay is, with all this proliferation of IoT devices and such, one of the ways to connect an IoT device is wirelessly. And the security of a 5G signal is much better than the security on a Wi-Fi signal. Just the nature of the protocol between them. That becomes an interesting use case with all of the reshoring, a lot of new manufacturing going on, a lot of automation. That's another thing that drives it. So kind of new manufacturing, automation, wireless connectivity drives a use case for 5G as a private network as opposed to a cellular network. The technology is the same, but in a private network, AT&T, Verizon, T-Mobile, whoever the carrier happens to be in the territory you're sitting in, they're not necessarily involved. In this case, Leviton would own that piece. That's ours. And that's how we're talking to our equipment. Our equipment is talking to the servers, whatever is directing, that activity. That becomes a much more tangible use case in 5G. Private networking existed in 4G, at least 4G LTE. But because of the speeds and the latency improvement, 5G is a much better business case for it in 5G than there had been before.
Okay. So it's looking at competing with enterprise wireless systems, like you said, manufacturing, industrial type facilities, having all those devices, all those machines and things that we want to keep track of. 5G is going to play a big part in that.
Yeah, I guess it competes with Wi-Fi. They're going to coexist, though. If you think of how Wi-Fi is used today, it's basically Ethernet, so you can plug it into your existing networks. The big benefit of Wi-Fi is you don't need a patch cord to plug into your laptop. I move from my office to a meeting in the conference room, or go visit a customer and I go sit down and I can attach their Wi-Fi. I don't need to actually plug into their network to do it. So that's a big advantage. I'm just giving a couple of examples.
Right.
But that just means you're untethered. You're not plugged in. The thing that 5G brings that Wi-Fi is not as good at is it's mobile. That while you're not just untethered, you're moving around, but you're still maintaining connection. That's what a cellular network, it has always been designed to do. So if you think of, driving in your car down the street, you can drive for miles and miles and miles and you never lose that phone connection. As long as there's another tower, another antenna to pick up that call. You relate that back into a industrial footprint. If it's on a piece of equipment that's just sitting stable and isn't moving around, Wi-Fi can work. That is often used today. But if it's on something moving around, say like a fork truck or a robotic arm, any other application you can imagine that the device is moving around, that's where 5G is going to give much better performance than a Wi-Fi connection.
Okay. All right. That makes sense. So talking about that, you talk about how you can maybe acquire service from one of the big cellulars like T-Mobile or Verizon, AT&T. But like you said, you can also have your own chunk, right, that you manage yourself. Where do they go to get that access to their own piece of 5G or own piece of cellular to use for a campus or a building?
So there's a variety of ways to do that, but it's kind of similar. In one sense, it can be similar to the way the carriers get their spectrum. There's set aside, there's a set of frequencies in the US referred to as CBRS, which is Citizens Band Radio System. So it's not in conflict, and they're not the same set of bands that AT&T or Verizon or T-Mobile have allocated. There it becomes a bit more like Wi-Fi. It's almost more like a TV station, really. I could have my allocated band. As long as the guy across the street from me doesn't use that too, we're going to be in good shape. But a guy that's 100 miles away, we're not going to bump into each other. So they could use that same bit of frequency multiple times across the country. So there's an agency set up to make sure that, those conflicts aren't happening. So that's one way. So kind of major organizations that are interested in private networking, that's kind of how they would do it. But there's another way of doing it, which is basically as a service. Everything today can be had as a service, and you can get private networking as a service. And I'll be talking to Nextivity in one of our upcoming episodes. That's one of the things they offer. They have a private networking as a service. So they set it up for you, and then, we'll end up paying them kind of a monthly fee to have access to that. So they take care of all the administrative stuff and all the back-end hardware. On our end, we just got to make sure that we have, basically, it's a SIM card, the same thing you have in your phone. You have a SIM card that goes into the equipment that is at our facility. As long as that SIM card matches with that private network settings, they're all going to talk to each other and everybody's happy. So there's multiple ways, but that's kind of the two extreme cases of how you would gain access to the private networking connection.
Yeah, that's great information. There's not much information that details, those specific aspects as to how you kind of get your own band. So we've kind of gone over 5G and the DAS systems as far as how they work. So, Leviton Network Solutions is a structured cabling manufacturer. If I'm a contractor, a distributor, or an end user listening to this, or, I'm going to want to know, what does Leviton Network Solutions have to do with DAS?
Kind of a couple ways to answer that, but I think the most immediate thing that comes to my mind is if it's communications related and it's in a building, that's what we do, space we play in. We've seen it in a bunch of industries. You think of our ULAN messaging. You mentioned talking about things 10 years ago. If you go back 20 years ago and you thought about network connections, all right, that meant PCs going back to, do we call them data centers? I'm not sure if we even called them data centers then. It was computer room. You connected your PC to the computer room. The phone was a whole different thing. You'd go to a building, that's the phone guy. And they had their own set of equipment and potentially closets and certainly different people. And now the phone guy is the data guy. It's the same thing. We're seeing that happening with more and more applications in the buildings where it's going across, even if it's not Ethernet, it's going across a traditional structured cabling environment, twisted pair in the horizontal and fiber in the backbone. We're seeing DAS can be no different. That's just another application that can be running across a structured cable plant. So as long as it's done well, and that becomes one of the big advantage of standards, as long as it's installed in a standards compliant way, manufacturers know what to expect. So they'll say, all right, I'll sell my equipment as long as you have Cat 6 or better, or, potentially 6A or better, whatever they want to define it as far as Leviton's concerned. And I would say kind of to a larger audience like Bixby, as long as everything's installed appropriately, there's all kinds of applications that can run over it. It's not just traditional data that's on that cable plant anymore.
Right. And then what about the back end? I mean, is this going to affect as far as throughput requirements, as far as backbone cabling or any other kind of distribution outside of the DAS system, or will it be its own entity?
I would say it's probably separate. Like, one of the things that I found kind of surprising, it makes sense when you hear it, but I never thought about it. But if you think of a data network going into a building and the main cross connect, typically, and let's say it's a 20-story building, some building in a downtown area.
Yeah.
Traditionally, that main cross connects in the basement. It's at the bottom, and you go up the risers to connect to the various closets. In a DAS system, it's usually the opposite, because the donor antenna is typically on the roof. And you want that donor antenna, the link between that donor antenna and the head-end equipment to be as short as possible. So a lot of times you'll see the DAS equipment on the top floor of the building or somewhere near the top, and then it pushes down to distribute the signal down lower. So there are kind of variations, but to the cabling, it doesn't matter. As long as the cabling is put in place correctly, again, it requires that the manufacturer of the equipment is designing this to run on structured cabling. So that's one of the things that it'd be good for people to be aware of. Make sure that you're taking advantage of, because not all DAS systems run on structured cabling. A lot of them run on the specific types of coax or something, which it works. It's just falls outside the scope of 568. There's an advantage to having baseline cable plant that you could put anything on. It could be a DAS today, maybe next week or next year, or the next tenant that comes into the building. They don't want to have a DAS system. They want it to be Wi-Fi. As long as it's standards compliant structured cabling, they can kind of put whatever they want on the end of it. When you have very specific types of cabling associated with the equipment, that's all it can ever be. So if the technology moves past it, now you've got dead equipment kind of strewn about the building.
Right. So the standardized structured cabling that, like you said, Bixby and the world that Leviton Network Solutions lives in, you have that kind of universal medium versus a proprietary technology where, like you said, it's only going to be useful for that one particular system.
Yeah, exactly. Again, go back in time. I'm not sure how many people are as old as me or older than me, but there was a time when, people bought a computer system from Wang or Digital Equipment or IBM for that matter. They all had their own cabling. The cabling was considered part of the computer network. Now, out of that grew the structured cabling, because at the end of the day, the market kind of came to the realization that if I want to switch from one computer vendor to another, I don't have to rip all the cabling out of my walls. Let's go to structured cabling. So in the data world, again, that has happened to the point that most people forget that prior world ever existed. But it still exists. Like if you get into HVAC systems or, some other building automation systems, there can be very specific types of cabling depending on which vendor you use. Those are the walls that are starting to come down now. The market saying, well, we got this cabling that's going from the 3rd floor up to the 7th floor. Why don't I just use that? That's where we're at now. And again, DAS is one of those example applications. That's the communications cabling. To a large extent, it doesn't really matter what the communications is, as long as it's designed to run on that type of cabling, we're going to be in good shape.
Yeah. So we've kind of gone through a lot of the different standards of, how the DAS systems are developed and have developed over the years and what they're doing for us in the structured cabling. What about the licensing part of it? Because, when we talk about DAS, we're talking about cellular. So we've talked a lot about if we own the band, but what about when you're just redistributing to have Verizon T-Mobile signals? What kind of requirements are required for the different types of DAS systems to connect? I mean, can you just connect to them and amplify those signals, or are there any legal permitting applications that need to happen?
So there's 2 broad categories of DAS systems: industrial systems and consumer systems. An industrial system goes into a place, think of, football stadiums, airports, potentially convention centers, any place where there's tens of thousands of people that are going to be simultaneously using the network. Because the issue there is not just coverage, there it's capacity. There's so many people that are trying to use that or get access to their signal simultaneously. Now there, because they're actually adding capacity, you have to have a retransmission agreement signed off by whoever the carrier is that you're trying to retransmit. And if it's a public space, like an airport, like a football stadium, effectively that means everybody, all of the carriers are going to be used in that environment. So there's kind of 2 things that people have to worry about there. One is get the retransmission agreement. 2 is on a case-by-case basis, the carriers, AT&T, Verizon, T-Mobile, have to come in and actually sign off on the installation before that can be turned on, because that can have a dramatic impact on their overall network. If something isn't engineered correctly when they put that system in the football stadium, it can have a negative effect on the whole surrounding area, which isn't going to make the rest of the customers pretty happy that don't happen to be going to that football game. Now, the other type of system, consumer, I should say on the industrial, usually people call that like a fiber DAS or an active DAS. You'll hear kind of terminology like that associated with it. For the consumer DAS, most commonly people refer to that as a passive DAS, or a BDA is another term that people use. In a passive DAS, we are not adding capacity. We're just trying to improve the coverage. You're still utilizing the carrier's signal, but because the power is more limited by the FCC in a passive DAS system, you don't need an individual retransmission agreement. So in a smaller sense, somebody could just go purchase their own passive DAS system and install it themselves. They still have to notify the carriers that it exists, that they have turned it on, but they don't need to get permission ahead of time. So in a passive DAS, somebody could decide to have it, and it could be up and running in a week. In an active DAS situation, it's a year, 18 months from the time somebody decides they want to have it and it's being turned on. But the signals that are on there are still owned by the carriers. They spent a lot of money for that. So they have the right, even in the passive DAS situation where there is no retransmission agreement, if for some reason there's something going wrong with that piece of equipment or that installation, it can still cause problems for the surrounding area. And carrier has the legal right to go in and say, you have to shut your DAS off because it's having a negative impact on the rest of my network. They own the frequencies. They're essentially, that system is put in place to allow people to try to improve it. And it makes it easier for that to be done, but it doesn't eliminate the responsibility for it to be done correctly.
Right. Well, this is great stuff. You're very knowledgeable, and I've definitely learned a lot. So this is episode 1. What do we have in store for episode 2? I know you're going to be highly involved in that.
Yes. In the next episode, going to be talking to Stephen Cowell from Nextivity, who's a manufacturer of a specific type of DAS system that works off of Twisted Pair, which we like it so much. One of the reasons why we like it so much. But the idea is to kind of get from his perspective, or on behalf of Nextivity, how do they see the market playing out? What are kind of market forces that they see, pro and con, for the different types of systems in the different places? Moving forward from that, the plan is to talk as well with contractors and end users and consultants to try and get bigger picture for the whole kind of ecosystem. Look at DAS as a technology. What does it mean from an installation contractor? Now, instead of just doing data networks, you're involved in, a piece of the carrier network. I hope that comes across through.
Yeah, that'll be valuable. Well, thanks again, Mike, and thanks to everyone else for listening, and we'll see you all at episode 2. Beyond Bandwidth is a podcast series produced by Leviton Network Solutions. For more information on the topics we talked about today, as well as other enterprise or data center network infrastructure content, or to check out all available episodes of Beyond Bandwidth, visit us on the web at leviton.com/beyondbandwidth, or wherever you normally listen to podcasts. If you enjoyed this episode, we'd appreciate you leaving an honest review in your podcast application. Along with word of mouth, leaving a review will help others find our show. I'm Roy Chamberlain, and this was Beyond Bandwidth. Until next time.